Hey everybody, welcome to topic number 10, graphing system of linear equations. So in the previous topic, we learned how to solve it. Looking for when we solve it by graphing, we do look for one specific point intersection. But here, graphing the system of inequality is actually looking for a region, or we call them solution region of points in the intersection of two half planes that satisfy the inequality. So this is not just this is a little bit beyond just a point of intersection. It's looking for a whole region of it. So you might have seen this before in your previous algebra class. When the inequality uses greater than or less than, we use dashed lines. Okay, when it's less than equal to or greater than equal to, we use solid lines. Normally, the way how we read, okay, how we read the inequality is read from the variable. So if I would say y greater than, right? If I read from the variable, this is y greater than. Compare that to reading it this way. Read from the variable, y is also greater than. So if you read from the variable, you are saying the same thing. Disregard which side the variable is on. As long as you read from the variable, you know exactly um, what you're looking for. So if it's greater than, if we say greater than, mean then we'll be looking for the region that is above the line. Less than means we're gonna shade below the line. All right, let me show you how this works. So consider the following system of linear inequality. Okay, number one, solve for the variable y in the first inequality. So this is the first one, second one. So 2x plus 2y less than 6, right? Solving for y. My variable term is positive. I'm going to let it stay there. Move the 2x over. I need to express it in terms of a slope-intercept form. So I will put the x right in front of the 6. All right. Inequality does not change. Positive 2x come over, become negative. Still positive 6. Divide every term by 2. So my y, if you read from the inequality, y is less than, right? We say less than negative x plus 3. So my slope, -1 means -1 over 1. My y-intercept, 0, 3. Okay, so my first line, I'm going to go to the line. Slope is -1 over 1, y-intercept, 0, comma 3. So I'm going to go to 0, 3, 1, 2, 3. Let me make this bigger. All right, down 1 to my slope, -1 over 1, means down 1 to the right 1, down 1 to the right 1, down 1 to the right. I'm just giving myself a few points. Okay, so we did say less than. That means we're going to use a dash line. Right, less than, not equal to using solid line. All right. So less than means we will look at the region that is below. Okay, look for below this line. All right, second equation. 6x minus 2y greater than equal to -18. So this time my variable term is negative, so I'm going to move it to the right, bring the -18 back. So inequality does not change. -2y come over, become positive. 6x still 6x. -18 come over, become positive. Divide every term by 2. So my y is less than or equal to. So if I read from the variable, less than or equal to 3x plus 9. Well, my slope is 3 over 1, y-intercept 0, 9. All right, so my y-intercept 0, 9 all the way up here. My slope 3 over 1. Up 3, it will take me out of the graph. So I'll go backtrack it. Down 3, 1, 2, 3 to the left 1. Down 3, 1, 2, 3 to the left 1. Okay, so this is less than or equal to, so that will be a solid line. So if you look at this line from left to the right, less than below this purple line, that's below the purple line is right here. So the region that intersect between the red, shaded in red and shaded in purple, got to be right here in this region. So any points right here in this region will satisfy the inequality of the two system, of the two equations. Okay, so that's my solution region, so that's the answer. Okay, let's try another one. All right, so this second equation, remember in topic A, we say x equal to number is always a vertical line. So this x does, it says x greater than equal to 3. So that is a vertical line, right? Because we're going to shade it to the right side of this vertical line. All right, so the first equation, 3x plus 5y less than 30. My variable term is positive. I'm going to let it stay there. Move the 3x over. So that's 5y less than negative 3x plus 30. Divide every term by 5. So that will be y is less than negative 3 over 5x plus 6. So my slope m is negative 3 over 5. Y-intercept 0, 6. Okay. I'm going to bring that graph up a little bit. Just big enough. Okay, so let's graph. All right, red one. 0, 6 is up here. Down 3 to the right 5. 1, 2, 3 to the right 5. That would be about right here. All right, less than, use a dash line. All right, no equal to, right? So use a dash line. Y is less than, read from the variable. So that will shade below. Okay, the next one, vertical line, x is greater than equal to 3. Vertical line look just like this, where all the x values are 3. So that will be 1 to the right, 1 from the origin, 2 to the right, 3, right? Just pick any 2 point, top and bottom, and draw a vertical line. But this time it says y is greater than equal to 3. Greater than is to the right of it. So as you can see, the shade, the overlapping in shade of the purple and the red, we're gonna be right here. So this is the region of points that will satisfy my entire system. There you go. That's my solution region. So we quickly talk about how to grab linear inequality, how to grab linear inequality. Okay, just by looking at reading the inequality and knowing where are the points that will satisfy the inequality. So you got, so this question number 1 coming straight from the lecture handouts. Okay, question number 2, same direction as all the handwritten portion. So make sure you solve for, so both of these equation 1 and 2 for this example are negative, right? So I do need you to move them to the other side and bring the term on the right back. So for the first one, you should have your inequality doesn't change. Negative 4y come to the right side, become positive. Negative 5x still on the left, the 20 come over, become positive. Divide both sides by 4. Make sure you write down your slope in the y-intercept. This one here, inequality doesn't change. I'm moving the negative 3y to the right. So that'd be positive 3y. 6x still 6x. Positive 18 come over, becomes negative. Then the next thing you do is divide every term by 3 and make sure you write down your slope and the y-intercept. And then using both inequality, to draw to find the solution region. Question number 3 is also on the handwritten portion, so it's the same thing as the one we just did, except this one has x greater than equal to 2. Your vertical line is shading to the right, vertical line at x equal to 2. All right, thank you so much for watching.